So let's do this last two application problems. So here we have a plane that's flying due north at 300 miles per hour when it is struck by a 40 mile per hour tailwind in the direction northwest with a 30-degree bearing. So what is the true speed and direction of the plane with respect to the ground? So a couple things going on. So let's first start drawing a picture. So here is my north-south, and then we have our west-east. So the first thing is that we have this plane, and you have the plane going due north. So let's say this is the origin and it's going upward this way. So here's our plane, and it's flying at 300 miles per hour. So basically this is a unit of magnitude and direction. So this is a vector. Okay, so there's the plane. I'm gonna write P for plane. And then it is struck by a 40 mile per hour tailwind. So you basically have this 40 mile per hour wind, and it's flying in the direction northwest. So it's basically going this way, northwest. Okay, so it's hitting it. So basically you can kind of think about like the entire plane isn't going north anymore. Now it's kind of like going this way. Okay, so and this guy is going at a 30-degree with a 30-degree bearing. Okay, so let me just try to draw the wind. Maybe I'm gonna draw a different system: north, south, west, east, and this guy's going this way with a 30-degree bearing. So remember, the bearing is hugging the north-south. Okay, so now what we want to do is you want to figure out what the true speed is and the direction of the plane. So the first thing that we got to think about is how can we describe these two as vectors? So we're going to look at the plane first. So let's look at the plane. So the plane, if you think about it, remember that in order for us to figure out how to write this in component form, we need to know the angle, and we also need to know the magnitude. So we already know the magnitude. The magnitude is 300. The angle, we actually already know it too. That's pi over 2, or 90 degrees. Okay, so what we're going to write 300 cosine of 90 degrees, comma 300 the sine of 90 degrees. Now you might be wondering, where are you getting this from? So remember when we were talking about, let me go back up a little bit, if I can find it. It was before this, right here. So see that you can use these guys to figure out the components given the magnitude and also the angle. So let's go ahead and go back. So we were finding the components for the plane. So that's basically what it is. So the plane is going to have components of the cosine of 90 degrees is just 300. And then this guy's just going to be, oh no, wait, that's wrong. The cosine of 90 is 0. So it's going to be 0. And then the sine of 90 is 1. So this is going to be 300. So this is basically how you're describing the plane. So the plane has this vector form. And now what we want to look at is look at the vector form for the wind. Okay. Now you have to be very careful with this, because with the wind, we know the magnitude, which is going to be 40. So the magnitude is 40 for both. 40 and 40. Now, what is going to be the cosine and the sine? Well, remember that when we're looking at that, we want to find the cosine and the sine from the positive x-axis. So we want to find this entire angle. So we already know that this angle is 30. I got to add this extra 90 degrees. So if I do that, I'm going to get 120. Okay, so that's basically what it's going to be. Okay, so now I'm going to go to my calculator, take 40 cosine of 120. That's going to give me negative 20. Okay, and then I'm going to get 40 times the sine of 120. And that's going to give me 20 square root of 2. I'm sorry, it's 20 square root of 3. Okay, so this is going to be the direction of the wind. So, and this kind of makes sense because this negative 20 should be in the negative x-axis. Okay, All right, so now what we want to do is we want to figure out what the actual speed is going to be. Well, what is the actual velocity of the plane? Well, the plane here, what's going to do is going to be attacked by this wind. So it's going to throw it off course. So basically what you're doing is you're taking this vector and adding it to the plane. So the plane plus the wind is going to give me the actual velocity or the actual vector. So I'm going to take the 0 and this 300, and then I'm going to add it to the wind, which is going to be this negative 20, and then 20 square root of 3. Okay, so this is going to give me negative 20, and then let me put this in decimal form. So 20 square root of 3. I'm going to get 334.6. Okay, so that's basically the actual vector form of where this is going. So basically, this particular plane now is going in this direction. Okay, it's going northwest. It's not going north anymore. Now, notice that it's looking for the speed. Speed is not a unit of a vector. This is not the speed. Okay, what we want to figure out is the magnitude of this guy. Okay, so the magnitude is going to be, so if you think the speed is going to be the magnitude, so the magnitude of this plane, so I'm going to write magnitude of the plane vector, it's going to be the square root of negative 20 squared plus 334.6 squared. So I'm going to get the square root of 20 squared plus 334.6 squared, and the speed is going to be 335.2, and this is going to be miles per hour. So that's going to be the magnitude. I'm sorry, yeah, the magnitude of that. So now what we want to figure out also, we want to figure out the direction at which it's going. So clearly, because it got thrown off course and it's going now northwest, you're going to have a new type of bearing. So how do we do that? Well, that's just going to be the inverse tangent. So the direction is going to be theta is equal to the inverse tangent of the y component, which is going to be 334.6 divided by negative 20. So I'm going to take the inverse tangent of 334.6 divided by negative 20, and I'm going to get negative 86.57. Oops. Let me just write 0.6. All right, now the thing about this is that notice that this doesn't make any sense because the inverse tangent is restricted. So basically the angle that you found was this guy. And what we want is over here. So basically this guy is going to be negative 86.6. Okay. So one thing that you can do to figure out what this angle is going to be, well, if this is 86.6, this guy should also be 86.6. Okay, so that small angle should also be 86.6. Now, what you want to figure out is you want to figure out what this angle is going to be. So you want to know this guy. Okay, so all you got to do is just take 90 minus this 86.6. So I'm going to take that 90, subtract by 86.6, and you're going to get 3.4. So that's basically the bearing. So this plane is going northwest at a bearing of 3.4 degrees. So this is going to be the direction. So you have now the vector of the plane after it was hit with the wind. You also have the magnitude of the vector, so how fast is it going now after it got hit with the wind, and you also know the bearing or the direction at which this plane is now going. Okay, so in the next video, we're going to do the last problem.